All right, balancing chemical equations, example number 2. So in this particular equation, we have nitrogen, hydrogen, yet again nitrogen, and yet again hydrogen. So let's follow through with the rules that were stated below. We need to divide the reactants and the products. Good. We have reactants here, products here. So the easiest way to remember which is to utilize the arrow. Okay? This arrow here, the arrow always points toward the products. Always. Now that we have that determined, clean this up just a little bit, create ourselves some more space, and we are going to follow these general rules that are stated down here. We cannot change a subscript, but we are allowed to change coefficients. So this 3, this 2, and this 2 are locked in place. There's nothing we can do to them. They are solid. Now we are going to be able to add, as you see with these dashed lines here, and I will add one here, right, to the coefficients. Right now, they're all assumed to be 1s because there is no coefficient. So we need to move on to step 3, which means to evaluate. Let's evaluate this. We have N stands for nitrogen, and we have 2 atoms of nitrogen because, again, there is no coefficient, so it's assumed to be a 1, multiplied by the 2. 1 times 2 gets you 2 nitrogen. Moving on to the hydrogen. Yet again, the coefficient is assumed to be a 1. That 1 multiplied by the 2 that is a subscript is going to give us 2 hydrogen atoms. Let's move on to the product side. We have the same exact elements. And we should do some math to come up with a balanced chemical equation. Currently, there is no subscript given for nitrogen, so it is assumed to be a 1. The hydrogen, on the other hand, has this 3 here, so it is a 3. So we have an odd set of numbers and an even set of numbers. The easiest way to begin this process is to look for least common multiples. Well, in my head, I know that 2 times 3 is 6, and 3 times 2 is 6. So I'm going to shoot for 6 in terms of my hydrogen as my least common multiple. That's where I want to start. And I'm going to, again, I always try to start on the compounded side because it does tend to make it a little bit easier. And if you don't want to, that's fine. I can respect that. It's not a problem. But that's just how I manage it. So I'm shooting for the target number of 6 in these hydrogens, right? So let's go with 2 because 2 times this 3 is going to produce the 6 that I want. So we need to change this to a 2 and this to a 6. At this very moment, we are not balanced. We have 2 and 2, but we have 2 and a 6. So we have to continue on through our journey. And as we move on, right, we know that we have to make adjustments to this H2. So what number times 2 is going to give us this target of 6 that we're looking for? Well, I think by now it's safe to say you all have graduated out of basic elementary level math, and you know the answer to that is 3. And let's go ahead and double check this. A coefficient of 1 multiplied by 2 gives you 2. Check. A coefficient of 3 multiplied by a subscript of 2 gives you 6 hydrogen. Moving on to the product side. A coefficient of 2 multiplied by a not given subscript for nitrogen of 1 gives you 2. And that same coefficient of 2 multiplied by the 3 hydrogen atoms is going to give you a total of 6. So, ladies and gentlemen, we have balanced a chemical equation a second time. If you continue to have questions, you continue to have struggles, please email me. I will get back to you as soon as humanly possible with perhaps more examples. We could also perhaps do a Google Meet. And tomorrow during class, I will hopefully be able to meet with some of you via Google. If you continue to have questions, please let me know via email. I'd be glad to help at any point. Enjoy the rest of your evening and hope to see all of you soon, happy and healthy.